ext and HFC file systems. Introduction. ext2. About ext2. The second extended file system is a replacement of the extended file system. The file system was created by Remy Card in 1993. ext2 was the default file system for Linux until ext3 came along. ext2 is still a favored file system for flash and USB drives due to lack of generating. Generating requires more write to the storage unit. The flash and the USB drive have a limited number of write cycles. File and directory are stored within inodes. Space of ext2. Block size 1 KB, 2 KB, 4 KB, 8 KB. File size 16 GB, 256 gigabytes, 2 terabytes. File system 4 terabyte, 8 terabyte, 16 terabyte, 32 terabytes. ext3. About ext3. The ext2 file system was extended by Stephen Tweedy in 1998 to produce the third extended file system. The file system was ported into the Linux kernel version 2.4.15 in 2001. The ext3 file system has the ability for an in-place upgrade from ext2. An in-place upgrade is when one file system can be converted to another. ext3 support generaling and all three of its type: general, order, whiteback. Some ext3 file system can support precedent pre-allocation. In this method, space is reserved or allocated for a file before it is written. Space occupied by ext3. Its block size 1 KB, 2 KB, 4 KB, 8 KB. File size 16 GB, 256 GB, 2 TB, 2 TB. File system 2 TB, 8 TB, 16 TB, 32 TB. ext4. About ext4. The fourth extended file system was originally started as extension to ext3 to improve performance and stability. After a while, the extension was included as a new file system, ext4. Files stored on a ext4 file system are stored in extend. Extend reduces fragmentation and improve performance. ext4 uses multi-block allocation to write multiple blocks at once instead of one block at a time to provide better performance. The method is also used with delayed allocation. ext4 supports online defragmentation. ext4 supports 256 kilobytes inodes. Space occupied by ext4. ext4 uses a 48-bit addressing system. This addressing system allows for a maximum file size of 16 terabyte. The maximum volume size is 1 exabyte. Generaling. Concept of generaling. A file system generaling record update to the file system can be recovered after a crash. There are two modes of generaling. Only metadata updates are recorded. All updates are recorded. Generaling in ext3 is done at block level. The first block in the generaling is general superblock and it contains the first logging data address and its sequence number. Updates are done in transaction and each transaction has a sequence number. Each transaction starts with a descriptor block that contains the transaction sequence number and a list of what blocks are being updated. Following the descriptor block are the updated blocks. When the update has been written to disk, a commit block is written with the same sequence number. This diagram shows how the generaling occurs. Three types of generaling. Write back. Here only the metadata is generalized and data is written to the file on the disk. In a crash, the file system is recoverable, but the physical data can be corrupted. Corruption can occur if a crash happens after the general is made of the metadata, but before the writing of the physical data. File system recovery is the worst, but the performance is the best. Second, ordered. This mode is the reverse of write back. The physical data is written first before the metadata is generalized. The order mode allows the data and file system to be uncorrupted if a file system crashes before the journal is written. File system recovery is medical. Third, data. In a data mode, the metadata and file content are generalized. System performance can be poorer than the other two modes, but the fault tolerance is much better. Concept of delayed allocation. Delayed allocation split file block allocation into two stages. First, reservation. Disk space is reserved when writing to cache. Decrement free block account. Create a virtual delocate extend. Second, allocation. Disk blocks are allocated when flushing data from cache to disk. Convert delocate extend to real extend. Benefits of delayed allocation. Fragmentation is reduced by combining writes and allocating extend in large chunks. Short-lived file may never needed to be allocated. File returned randomly can now be allocated contiguously. Here is the link where you can study about identify file system. HFS. Introduction. The Mac OS Extended Volume Hard Drive format, otherwise known as HFS Plus, is a file system found on Mac OS 8.1 and later including Mac OS X. It is an upgrade from the original Mac OS standard format known as HFS or hierarchical file system supported by Mac OS 8.0 and earlier. Up from HFS, HFS Plus increased the number of allocation blocks on the disk and decreased the minimum size of the file, thus optimizing the storage capacity of a large hard disk. Therefore, HFS Plus allows for a larger maximum number of files than its HFS counterpart. It uses Unicode to name file, encoded in UTF-16 and normalized to a form similar to Unicode normalization from DNFD. Here is the example. On a 4 GB hard drive, a file containing 4 KB of information would require 64 KB of space with HFS. With HFS Plus, it would only require 4 KB on the 4 GB hard drive. This is because HFS allocation block size would be 16 KB and HFS Plus increase of allocation block of the disk and decrease minimum size of the block allow for less wasted space. Volume and file limit in Mac OS X. Benefits of HFS versus HFS Plus. Typically, the HFS Plus file system is better than its predecessor, but there is one case where the Mac OS standard beats out the Mac OS extended format. Volume data is smaller than 32 GB cannot be initialized as Mac OS extended format. Upon attempting a hard drive setup, application HFS Plus will give an initialization failed message. Floppy disk cannot be initialized with the HFS format. Structures of an HFS Plus volume. First, boot block. Second, volume header. Third, allocation file. Fourth, catalog file. Fifth, extents overflow file. Attribute file. Startup file. Alternate volume header. Last sector. Flash file system. A flash file system is a file system designed for storing file on flash memory devices. These are becoming more prevalent as the number of mobile devices is increasing, the cost per memory size decreases, and the capacity of flash memory increases. Why disk file system cannot be used for flash drive? First, erasing block. Flash memory block have the explicitly erased before they can be returned to. The time taken to erase block can be significant, thus it is beneficial to erase unused block while the device is idle. Second, random access. Device file system are optimized to avoid disk seeks whenever possible due to the high cost of seeking. Flash memory devices impose no seek latency. Third, Wear leveling. Flash memory devices tend to wear out when a single block is repeatedly overwritten. Flash file systems are designed to spread out write evenly. Summary: Linux support ext file system among others, while Mac OS support HFS. inode is the primary metadata structure for the file in ext2. ext3 add transaction-based generalizing mechanism. ext2 plus generaling is equal to ext3. ext3 plus extend for memory reservation plus delayed allocation is equal to ext4. Delayed allocation performance feature that oversees the memory is allocated by the file system to the file when it is being written back. This reduces fragmentation. Flash file systems are used in case of embedded flash storage. In case of USB sticks, they can they have their own controller that look after varying level algorithm.